Hi, I'm Synthchaser from Synthchaser.com. Last year we did a 3-part video series repairing an Oberheim Four Voice. Now I've got a couple more Four Voices in for repair, and I thought we'd check one of them out together. This Four Voice is in for what should hopefully be a quick and easy repair. The main complaint is that when turning on the portamento, the SEM in the 3rd position drops down to LFO type rates. Now if I turn the portamento knob, so another problem that I noticed right away was that the SEM3 isn't scaling the same as the others. So here's, let's put it in unison mode. We already sound pretty far off here, and show you it's all coming from SEM3. So that one is not scaling correctly, and also, so this patch that we have dialed up is just VCO1, and you can see the initial frequency for VCO1 is about pretty much all the way down on SEM1, SEM2, but on SEM3 it has to be higher to get to that same frequency. There's SEM4, so that'll be something that we want to address as well. For starters, let's just take a look at the problem with the portamento. In Synthchaser 148, I gave a high-level overview of how the Four Voice works internally. The control voltages that are fed to this slot come through the programmer and the polyphonic keyboard assigner module. On the Four Voice, slots are called channels. The programmer and the keyboard assigner have 4 copies of the same circuit, one for each channel. Since the portamento control is on the keyboard assigner, it makes sense to first confirm that the problem is with the 3rd channel of the keyboard assigner. So here I've taken the keyboard assigner out. This module is made up of a whole stack of circuit boards. The deepest board in the stack has the pots and switches. The next board has the overhead logic, and the remaining 2 boards have the channel logic, with 2 channels on each board. Coming to the top of the circuit boards are different Molex connectors that serve different purposes. Here on the overhead logic board, this connector brings in the power. This connector is for a keyboard control voltage for the filters on the SEMs. And this connector goes to the keyboard, which is a matrix style keyboard that's scanned by this module. And these 4 connectors, one of which got pulled out when I took the module out, are the gate and control voltage outputs for each of the 4 channels. So this is where we're going to want to look to confirm our problem is with the keyboard assigner. So how do we know which connector is for channel 3? Well, as you can see on the cable that got pulled out, the housings are numbered. If for some reason they're not, there are jumpers here that configure, since this is the same circuit board that's used for channels 1 and 2 and 3 and 4, and in an 8 voice, 5, 6, 7, and 8. These jumpers are configured to identify which channels they are. These Molex connectors that basically stack the boards together are used for inter-board communication. So when the boards share data, that's done via these connectors. So conveniently, our channels 3 and 4 board happens to be on the bottom, or when you flip it upside down, the top of the stack, and is therefore the most accessible for troubleshooting. But because of the nature of this, we could, if we needed to troubleshoot channels 1 and 2, we could simply swap these boards in the stack and everything would work exactly the same. So let's measure our keyboard control voltage for channel 3. So this one here, this connector here should be channel 3. This one should be channel 4. And there are 3 different wires coming out of there. There's the gate, which is the green. So if I go on the green, there's our gate. The white, which is our ground, and it doesn't change. And then the colored wire, which is different for each of the 4 SEMs, is the keyboard control voltage. So let's take a look at that here. And actually, tweak this. Looks like we actually have a sine wave output there, or half a sine wave output. So here's our control voltage output from channel 3, and for reference, here's channel 4, which is a nice DC voltage, like it should be. So even with portamento turned off, it looks like we have an issue there on channel 3. So let's go ahead and turn portamento on now and see what happens. So here's our channel 3. And whoa, there goes our control voltage. So it's way down there now. Still got that AC component to it, but it looks like it's got a negative 7 or 8 volt DC offset. Let's compare to channel 4, which appears to be unchanged. So basically now we've narrowed the problem down to channel 3 of the keyboard assigner. Let's use the schematic to follow the portamento from the knob and switch to the channel logic board. So here's the portamento pot and switch on the overhead logic board schematic. We can see when the portamento switch is off, like it is in the schematic diagram, the voltage at connector G1 will always be at ground. When the switch is moved to the on position, the portamento pot acts as a voltage divider between roughly 15 volts and ground. This 2.2K resistor is there to limit current through the pot. The op amp here is just a buffer that increases the impedance to the next stages of the circuit. So this output node is labeled PC, perhaps for portamento control. So now if we look at the channel logic, we can see the part of the circuit using PC for each of the channels is limited to this little area here. PC is connected to the collector of this transistor, and the base current is determined by these 4 nodes, P1, P2, P3, and P4. Going back to the overhead logic, we can see these 4 nodes, P1 through P4, come out of this mess of logic gates and switches. We don't need to decipher all this at this point. It's pretty obvious what it does just by looking at it at a high level. This switch determines the grouping of the channels, and this switch assigns portamento to one or both of those channel groups. So P1 through P4 must be a logical on or off for the portamento for each channel. So if P3 is low, this transistor will be reverse biased and the portamento will be off. When P3 is high, this transistor will be properly biased and it'll pinch off this PNP transistor, driving the LED in this Vactrol. A Vactrol is an old school opto isolator. The brighter the LED portion of the LED shines, the lower the resistance of the photoresistor portion of the Vactrol. This capacitor and op amp here after the Vactrol is a sample and hold for the control voltage output for this channel. See, odd CV out. The op amp ahead of the Vactrol is also a buffer for the control voltage generated by the DAC. So when the resistance of the photoresistor in the Vactrol increases, it'll take longer to charge or discharge this memory capacitor, and the control voltage will glide from one point to another instead of stepping. Now that I've explained how the portamento works, we can troubleshoot this circuit and figure out where it's gone wrong. And the great part is on the same board we have another working channel that we can compare it against. So let's compare, so here's our Vactrol. This is the input side, the LED side, this is the photoresistor side. Let's check out the voltage drop on our good channel versus our bad channel. So I've got portamento turned all the way up right now, but I have it turned off. So here's the output of the Vactrol, and you can see that there's a very little voltage drop across this. This is 1.88 volts. This is 1.20 volts. So with portamento off, I've got about a a 0.6 voltage drop there. On this side, this is just sitting at ground, and this is just sitting at ground. So let me turn on Portamento now, and let's check the voltage drop on the good side and the bad side. So on the good side, the voltage drop, see now it drops more because that resistance is higher. So that voltage drop is now closer to 15 volts. And on the bad channel, the voltage drop is still 0. So to narrow down the problem, I took the Vactrol out for channel 3. And what happened is, there's channel 4, 2 is unplugged, and 3 is now silent. So let's, there's a click. So 3 is now ultra low frequency. So let's take a look at those op amps before and after where the Vactrol was and see what's going on. With the Vactrol out, there is a 3.3 meg resistor there that feeds that memory capacitor. So I would expect to hear the correct pitch, but I would expect to have a really long portamento, whether or not I have the portamento switch turned on. So let's take a look at these op amps before and after where the Vactrol goes. So there's a TL081 here, so we're going to be looking on pin 6. So for reference, here is the control voltage for channel 4. So we're sitting at, what are we, 5 volts per division, so probably like a volt or 2 volts. For channel 3, that appears to be about the same. So ahead of the Vactrol, we were fine. So then there's also the sample and hold after the Vactrol, and that's a 308 op amp, and we're going to be looking for our output also on pin 6. So for the good channel, channel 4, our output is the same, approximately 1 volt. For channel 3, our output is way down in the negatives, and you can see that the line is thick here. I think that's where we're getting our oscillations on the control voltage. So our problem actually appears to be with this final op amp used for the sample and hold, not the Vactrol or the Portamento circuit at all, actually. Okay, so I went ahead and replaced this 308 op amp with a new 308. Yes, I actually have 308 op amps in stock, and this is what's happening now. That's 4 on, 2 is disconnected, and there's 3. And you'll notice 3 is higher because previously we had to tune the VCO higher to get it to match the pitch of the other SEMs. So it looks like this op amp was dragging its input down. When the Vactrol was in place, you'll recall that when Portamento is off, the LED is shining brightly, the photoresistor is basically 0 resistance. So there was very little resistance path to keep charging that memory capacitor. But even so, this was draining it down far enough that that you had to turn the VCOs, that you had to turn the CV higher than what you actually needed it to be to get it what you wanted it to be, and it was causing those oscillations. We'll take a look now at pin 6 on this capacitor, and you'll notice that those oscillations that were there on the control voltage are now gone. And when Portamento was turned off, it was kind of pinching off the current to the LED on the Vactrol, and the resistance was growing higher and higher, and at that point it just couldn't keep up, and the control voltage dropped into way negative range where it shouldn't have been. So I'm going to go ahead and put that Vactrol back, since there's probably nothing wrong with it. So I put the keyboard assigner back in, and we can now can now hear another issue with the keyboard, and that is SEM4 isn't scaling with the others. So we'll turn that one out of the mix. That's 1, 2, and 3. So in terms of scaling and tuning SEM3 or channel 3, we're fine once we fix that problem. And we can turn Portamento on. And channel 3 is working just fine. The keyboard assigner and the programmer and the 4 voice and the 8 voice scare off a lot of people. But personally, I find them to be really fascinating pieces of technology. Anyway, I hope you found this to be another interesting look at an Oberheim 4 voice repair. I'm Synthchaser from synthchaser.com. Thanks for watching and have a great day.